So example 3, it says a point P03 is a solution for the differential equation is on the solution for the differential equation y over dy over dx equals y cos x. So this at x equals 3, x equals 0, y equals 3 on the y equation. It says find the tangent line at point P and use it to approximate the value of y when x is 0.1. So notice that 0.1 is close to the 0, 3 tangent point. So for our linear equation, we need a point. We also need slope. So I'm going to calculate my slope, and I'm going to use my dy by dx equation to calculate slope. So dy by dx, when x is 0, y is 3, I can plug it into that equation, so I get 3 cosine of 0 So I get 3 for y times cosine of 0. Cosine of 0 is equal to 1. So I get a slope value that is equal to 3. So then find the tangent line of P at point P, the tangent line that approximates the y value. I'm going to write that as L of x. My tangent line equation is going to be my slope, x minus 0. Okay, again, I'm using point slope form, plus y equals 3. So 0, 3 shows up in my point slope equation. That's my tangent line equation. And using it to approximate the y value at x equals 0.1, I'm going to say that the y value at 0.1, and maybe I'll just do a different color here. So when we're talking about the y value, maybe I'll do this in green, indicating that's the y in this equation here. Okay, that y value in the equation at x equals 0.1 is going to be approximated by the line, the straight line at x equals 0.1. And so when I put that in there, I'm going to get 3 times 0.1 plus 3, which is 3.3. So the y value on the solution curve at 0.1 is approximately, it's close to 3.3. Now, the problem does not ask me to solve for y, but we can solve for y because we can separate this and integrate it. So this is a separable differential equation. So dy by dx is equal to y cosine x. Okay, so then we separate our y's with our dy. So dy goes with y, so y comes in the denominator. And then I'll just color code that. So my y and dy go together, and that's not y. So my y and dy go together, and my x and dx go together. So cos x, and the dx goes on this side with the cos x. So that's going to be these parts here. The x and cos x go together. Once we've separated, we can integrate both sides. So this becomes log y is equal to the antiderivative of cos is sine. And then we have a plus c that we have to worry about. Now we can solve for this plus c by plugging in the coordinates. Now I'm going to solve for the plus c once I solve for y. So I get y equals sine x plus c. That plus c can show up as a coefficient, and it becomes y equals e to the c, e to the sine x. And that e to the c, that whole thing represents a constant value that we can solve for. And then plugging in for x and y, we end up with y equals 3 when x equals 0. So sine of 0 is 0, e to the 0 is 1, so we get 1. So we end up with the e to the c is equal to 3. So the equation, my final equation then, the solution equation is going to be y equals 3e to the sine x. And then we can test our coordinate. We can check the coordinate on y. So we can actually plug in y at 0.1 in this equation when we do 3e to the power sine x, or in this case sine 0.1, we get a value of 3.3149. So I'm going to round that to 1.5, and we can see that the approximation in red of 3.3 is close to the actual value of 3.315.